What's good, everybody? It's your boy, Professor Peters. So today in my video, we're talking about parallel lines and how to find the equation of a line that passes through a specific point and is parallel to another line. And the way that we're going to do this, guys, just understand that parallel lines are lines that run next to each other with the same slope and they're not going to intersect. And the formula that we use with these type of problems is going to be called the point slope formula. And it looks something like this. We have y minus y1 is equal to m, and then in parentheses x minus x1. So before we start really breaking down the problem and substituting numbers, let's really speak about what this equation stands for. So we should know that with the point given, we have our x1 term and our y1 term. So where we see x1, we're going to substitute 12, and where we see y1, we're going to substitute 5. But oftentimes, students get confused with the first y and the other x, right? That don't have that little small 1 next to it. The reason it gets confusing, guys, is because those are just standard, meaning it's always going to be there. They're not going to change. It'll always stay as y and x. And as I solve this problem, I'm going to explain what I mean. So we have y stays the same minus y1, which is 5, is equal to m. And guys, understand they gave us m. It's in the original equation, 2 over 3. So we're going to substitute 2 over 3. And then after we substitute, we need to make sure that we distribute that 2 over 3. So 2 over 3 times x is just going to be 2 over 3x. And now we're going to substitute 12 in. And once we do that, let's just make sure we get this right. We have 12 over 1. We're going to make it a fraction, right? Because we're multiplying fractions. And we're going to have 2 over 3. And once I multiply straight across, this is going to give me a negative 24 over 3. And we're going to simplify that to just negative 8. All right? So at this point right now, guys, we're on fire. We understand what's going on, right? We have the correct formula. We made the necessary and correct substitutions, right? Y1, x1, and we took care of the fraction and simplified. Now, what is next? And what is next, guys, is that we are now going to try to get the y absolutely by itself. And the only way we can do that is by moving and combining our negative 5 with its like term, which is negative 8. So for us to do that, we're going to have to do the opposite of subtracting 5, right? This negative 5, right? So we add 5, right? Go on the other side, do the same thing. And now my final equation would be y is equal to 2 over 3x minus 3. Now, when I step back and I compare my answers, meaning the equation I just got and the original equation, I'm noticing that they do have the same slope, 2 over 3, and that their y-intercepts are different. And that's a very important thing because these lines are not supposed to intersect. All right? But before we wrap this problem up, I want to go back and show you another cool method that I've found where you could solve this. And it does work in most instances. And I want to share it with you guys today. All right, so let's go back. Okay, so we go back to the original problem. And we're going to finesse, just meaning work. We're going to work this out just using the regular slope formula, right? And I understand, guys, this is what makes math so complicated because there's so many different methods to get the same answer. But I'm showing you both these ways so that you could pick something that works best for you, what you feel more comfortable with. And please make sure you practice because it does take a lot of practice. So right now, the biggest thing is we're trying to find the y-intercept, right? Because we don't have the y-intercept. So this is what we're solving for to complete this equation. What I do know is my slope, 2 over 3. So let's start plugging some things in. So I have 2 over 3, right? X point that we're talking about is going to be 12. So I'm going to keep it as a fraction, 12 over 1, bring this down, plus b. And then on my other side, right, remember that y, based on the point given, is 5. So now we're going to see if we can rework this problem and get to our previous answer, which was y is equal to 2 over 3x minus 3. Let's see if with this method we get the same exact answer as the previous method that we used. So now I'm going to start solving so I could get b by itself. On this side, we're going to have the same 24 over 3 once we multiply our fractions plus b. So to simplify this, let's turn it into a whole number, right? 5 is equal to 8 plus b. And now for us to understand and figure out what b is, we are now going to combine our like terms. And for those of you that are good with integers, after I subtract, you're probably going to notice that we are going to get b is equal to -3. So what does that mean, Mr. Peters? That means when we take y is equal to, and we know that these lines are supposed to have the same slope, 2 over 3x, we can now go ahead and take that y-intercept that we figured out and put it at the end of our equation. And lo and behold, we have the same exact answer. So like I said, guys, if you like this second method better, please comment down below. I can do a video where I practice more on it. But please make sure you guys practice before you start doing it on your homework assignments, okay? All right, so we're going to go ahead now and we're going to go on to our second problem. And in this second problem, this is a very important and vital problem because there's a big common error that a lot of students make. And I want to make sure that you guys are prepared so you will not make that same common mistake. So the point is going to be a little different now. It's going to be -3 comma -1. And let's just identify the x1 and y1 for now, just to get it out the way, right? X1, y1, and the equation, or the line should be parallel to the equation. Y is equal to 2x plus 3. So for video purposes, I'm going to stick to just the point-slope formula now, okay? So let's rewrite that. Y minus y1 is equal to x parentheses x minus x1. So we know that the y and x with no number next to it, that's standard. It's not going to change, okay? What we're worried about is y1 and the next one. So let's go through and substitute now, right? Because we have all the information we need. So y minus -1. So whoa. This is where everyone makes the mistake. They think because there is a subtraction sign here that they're just supposed to put y minus 3, but oh man, guys, I'm sorry to say that this would give us the wrong answer. So what I want you guys to make sure that you do is to include that sign. If we're subtracting already from the formula and the number's negative, put it in parentheses, because this is how it should be. This is the correct setup. And now this is equal to 2 times x, right? Let's set it up like this. And then we're going to do minus, right? And then understand that our x is similar to the y. It's negative. So once we plug it in, I'm going to put it in parentheses, right? We're going to be subtracting a -3. Now, if everybody remembers integers and adding and subtracting positive and negative whole numbers, you guys know that when we subtract a negative, it's actually going to turn positive. So this is the big trick right here. And man, so many people get caught by it sometimes, but I know you guys aren't. I know y'all got this. So I'm just going to rewrite this and change the signs just to clean it up. Y plus 1 is equal to 2x, 2 times positive 3 plus 6, right? So now we're in business, and you guys know what is the overall goal? Exactly. We are trying to make sure that we solve and get y by itself so that we could compare both of our equations to determine if they are parallel or not. So at this case, this step here, we just have to combine our constants. So I'm going to subtract 1 from both sides. And now I'm going to have y is equal to 2x plus 5. And once we compare both of these, let's circle them or box them off, I should say. Same slope, that's the first thing. And now we have a different y-intercept, meaning these two lines should not intersect. Because if they intersect, then they're not considered parallel. Exactly. All right. So I'm not done yet. We got one more question. All right. And in this question, it's going to be a different format. And please make sure you guys stay around because you're gonna want to know this little hack. It's a definite trick that they always throw on standardized tests too. All right. So what they're saying now in this last problem is they're going to give us two lines, or not necessarily two lines, I'm sorry, two equations. Equation number one is y is equal to negative 2x plus 3, right? And then our second equation is 2x plus 7. Is it plus 7? Nope, I'm sorry, plus y is equal to 7. Now, before I go on and say anything else, guys, understand that the best way to compare these two lines, these two equations, is to put both of them into slope-intercept form, right? Because once they're both in the same format, it's more easier for us to compare the slope and compare the y-intercept. So what does that mean, guys? Or what does that mean, Professor Peters? I got y'all. So for one, we do not need to do anything with equation number one. That is a trick. They will make it seem like you have to do something. Oh, no, 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 you don't. There's nothing to do. We need to focus on the second equation because guess what? It's not in the same, it's not in this form, y is equal to mx plus b. So for us to get it in the same format, right, or form, I should say, we're going to maneuver or manipulate this equation by subtracting 2x, right? So now we have y is equal to, and I know you guys know this, but I'm just going to test you. Can we combine these? No, they're not like terms. This has an x, this is no x, so they're not the same. So I'm going to put y is equal to 7 minus 2x. And because I want to make sure we're all on the same page, I'm going to flip the order of this so it matches these two formats exactly. Because we don't want to make no errors, right? So now y is equal to, this is negative 2x. I don't see a negative sign out in front of here, so I must assume it's positive, right? Plus 7. So now, once we compare this equation and this equation, what do you guys see? I see same slope, negative 2, different y-intercept, right? So please, guys, make sure that when they ask you to compare two equations, two lines, make sure that they're both in slope-intercept form, right? And please make sure that you're comparing the y-intercepts and especially the slopes because they have to be the same. So thank you guys so much for joining me today. This is Professor Peters. My next video, I'm going to be talking about perpendicular lines. And don't forget, Wednesday, we will be having another live session, 6:30 p.m. Eastern Standard Time. The topics will be posted in our community tab. Thank you guys so much for joining me today, Professor Peters. See you guys later.